Welcome to the show. Today, we're diving into how cyber forensics has evolved as digital threats become more sophisticated. To start, could you explain why traditional forensic methods are struggling to keep up with modern cybercrime?
Absolutely. Traditional methods often rely on manual data review and linear investigation processes. But with the explosion of digital data, think billions of emails, logs, and transactions, manual analysis can't scale effectively. This gap leaves room for threats to go undetected.
That's a stark picture. So, as the volume and complexity of cyber threats increase, what new tools are investigators adopting to bridge this widening gap?
Investigators are increasingly turning to artificial intelligence solutions, especially machine learning, natural language processing, and computer vision, to help automate and accelerate evidence analysis. These tools can sift through massive datasets in minutes, uncovering patterns that humans might miss.
Let's zero in on machine learning. How exactly is it revolutionizing anomaly detection in cyber forensics?
Machine learning excels at recognizing unusual patterns in data, such as network traffic or system logs. By establishing a baseline of normal activity, algorithms can flag deviations like a sudden spike in file transfers at midnight that might indicate a breach.
That sounds powerful. Could you give a real-world example of how this works in practice?
Certainly. In a 2023 case, a financial institution used clustering algorithms to detect subtle anomalies in employee login times, which led investigators to uncover an insider attempting to exfiltrate sensitive data. The algorithm processed millions of log entries far faster than any human could.
Transitioning to another AI domain, natural language processing or NLFARs become vital in cyber forensics. Can you break down how NLP is used to analyze textual evidence?
NLP algorithms scan emails, chat logs, and documents for suspicious language patterns. They can detect intent, sentiment, even coded language. For example, they might flag a phrase like, "the package has arrived," as a potential indicator of illicit activity, depending on context.
Interesting. Are there limitations to what NLP can discern in complex investigations?
Great question. While NLP is adept at pattern matching, it sometimes struggles with context or sarcasm. However, advances in deep learning models are making these systems better at nuanced understanding, especially when they're trained on domain-specific datasets.
We've covered text, but what about images and video? How does computer vision enhance cyber forensic investigations?
Computer vision uses AI to scrutinize images and videos for signs of tampering, such as inconsistencies in lighting or digital artifacts. It's crucial for detecting deepfakes, videos manipulated to convincingly impersonate someone, which are increasingly used in scams.
And what's the process for verifying the authenticity of such media?
Advanced systems analyze facial movements and metadata, looking for anomalies impossible to replicate perfectly. For example, GetReal Labs software examines microexpressions and pixel-level inconsistencies to distinguish genuine footage from deepfakes.
On that note, GetReal Labs has gained attention for its real-time deepfake detection. Can you tell us how their technology works and why it's so significant?
GetReal Labs utilizes AI-driven forensic analysis during live video calls. Their system examines subtle cues like unnatural eye blinks or mismatched audio-visual sync and cross-references image metadata, flagging manipulations in seconds. This is critical as deepfake scams increasingly target remote hiring and financial transactions.
That's a game changer, especially as remote work grows. Are companies widely adopting this kind of technology yet?
Adoption is accelerating, particularly in sectors vulnerable to impersonation, like finance and HR. However, there's still a need for broader awareness and integration, as many organizations underestimate the risks posed by deepfakes.
Shifting gears, Interpol's Innovation Lab in Singapore seems to represent the future of collaborative cyber forensics. How does this lab enhance global law enforcement capabilities?
The lab acts as an international hub, equipping agencies with tools like underwater drones for digital evidence recovery and robotic dogs for site inspections. Their digital forensics section can extract data even from damaged devices, such as burnt phones or encrypted car systems, often critical in cross-border investigations.
That's impressive. How does this multidisciplinary approach benefit investigations compared to traditional methods?
By integrating robotics, AI, and forensic science, the lab enables faster, more comprehensive evidence collection and analysis. For instance, they can reconstruct crime scenes in 3D, which aids both investigation and courtroom presentation.
Another frontier is the dark web. How are AI tools aiding investigations into these hidden online marketplaces?
AI systems crawl and categorize vast amounts of dark web data forums, encrypted chats, illicit marketplaces. By clustering related posts and identifying linguistic signatures, AI helps trace illegal transactions, such as drug sales or ransomware negotiations, that would otherwise be invisible to law enforcement.
Are there any notable successes from using AI on the dark web?
Yes. In 2024, a Europol-assisted operation employed AI to map connections between vendors and buyers across several markets, leading to dozens of arrests. The AI flagged transaction patterns and cross-referenced digital wallets, expediting what would have taken years manually.
As promising as AI is, integrating it raises significant challenges. Let's talk about data privacy first. How do forensic teams balance analysis with privacy concerns?
It's a delicate balancing act. Investigators must ensure compliance with data protection laws like GDPR by minimizing unnecessary data access and employing techniques such as pseudonymization. Oversight mechanisms and regular audits are essential to prevent overreach.
And what about bias in AI models? We've seen this issue in other sectors. Does it impact forensic investigations too?
Definitely. If an AI model is trained on biased datasets, it can produce skewed results, potentially misidentifying suspects or overlooking key evidence. Continuous retraining, diverse data sources, and human oversight are vital to mitigate these risks.
Finally, there's the question of accountability. If an AI system makes a mistake, who is responsible?
That's a tough issue. While AI can guide investigations, final decisions should rest with human experts. Establishing clear guidelines for responsibility and transparency in AI decision processes is still an evolving area in digital forensics.
Given these challenges, what steps are being taken to establish ethical and regulatory frameworks for AI in cyberforensics?
Industry bodies and governments are developing guidelines like the EU's AI Act and the US NIST AI Risk Management Framework focused on transparency, auditability, and fairness. These aim to ensure AI tools are used responsibly and with respect for civil liberties.
Are there any best practices for organizations implementing AI in their forensic workflows?
Yes. Best practices include regular bias assessments, transparent documentation, stakeholder training, and establishing multidisciplinary review boards. These steps help align AI deployments with ethical obligations and public trust.
As we look ahead, what are the most exciting opportunities for AI in cyberforensics, and where do limitations remain?
AI's potential lies in automating complex analyses and providing real-time threat detection. Hypothetically, we could see AI agents working alongside human teams to instantly reconstruct digital crime scenes. However, limitations persist in interpretability, data quality, and ensuring ethical use.
Do you foresee a future where AI could independently conduct entire forensic investigations?
While AI will certainly take on more analytical tasks, human oversight and judgment will remain crucial, especially in legal contexts. The ideal future is a partnership. AI handles the heavy lifting, while investigators focus on strategy, oversight, and ethical considerations.